Hello, my name is Michael Crowley. I'm a Principal Engineer at Farm Technology, and I'm here today to introduce our new 60 gig communication link extension system. The system consists of an up converter and a down converter to simulate any standard 60 gigs communications. The up converter takes an externally supplied local oscillator from any standard 20 gigs low phase noise signal generator and conditions it and mixes it with an IQ signal to transmit from 57 to 66 gigahertz, and the receiver then can receive that signal again in the same band, 57 to 66, and down convert it again using an externally supplied local oscillator from any standard 20 gig signal generator to an IF signal that can then be analysed by a standard oscilloscope with the relevant software for analysing communication systems. In this example, we're using an Keysight M8190A arbitrary waveform generator to supply a very standard 16 QAM IQ signal on a 6 GHz carrier that is being fed into the IF input of the up converter, which goes through a dual stage of up conversion to allow for sideband filtering and various signal conditioning to be transmitted. This system has a P1 dB of roughly 20 dBm, so there's a wide bandwidth of power operation where you'll be able to operate in the linear band of the system. That's then in this demonstration being transmitted at 65 gigahertz, and we have a receiver at 65. The receiver then takes the 65 gig signal and mixes it through a low noise amp with a 60 gig LO, which is supplied by a 15 gig LO input, and it's conditioned multiplied by 4 internally to give a 5 gigahertz output, which is then in turn analysed using a DSA-X from Keysight running the VSA 89600 software, which is showing a very good cluster of 16 QAM with an error vector magnitude of roughly 3 to 4% on the basis of the IQ signal being input to the unit with an error vector magnitude of roughly 1%. And just to show that we are actually transmitting a 65 gigahertz source or signal. Thank you for your attention.